So our essential question for this lesson, how do we make and use box plots? Okay, so a box plot, it's a way to organize data into 4 equal groups. Okay? So we use box plots to split our data up into 4 equal groups. One number that we need to find to make our box plot is the lower quartile. Okay, that's the median of the lower half of the data. So I'll show you what that means with a data set here in just a second. Okay? Once I show it, the definition makes a lot of sense. So if you're not sure, that's okay. We're going to figure it out here in just a second with the data set. So the lower quartile is the median of the lower half of the data. So you have to split the data in half, and then you find the median of the lower half. That number would be the lower quartile. Then we also have an upper quartile. So you take the upper half of the data and find the median of the upper half, and that is the upper quartile. So it's the median of the upper half of the data. There are 5 numbers that we need to be able to make a box plot. I just defined 2 of them, the lower quartile and the upper quartile, but I'm going to write them down in a particular order. Okay. So 5 numbers needed to make a box plot. First, the minimum. Okay, so you need the minimum value of the data set. This is usually one of the last numbers we find. We don't find them in this order, but this is the order in which the numbers value-wise are usually in. So the min, the lower quartile is the next number in the list. And these are the abbreviations on the right-hand side. So right here I have the abbreviations for those values. So instead of writing the whole word minimum, I usually abbreviate it and just say min. It's just a short version. Lower quartile, instead of writing the whole thing, I just write LQ for lower quartile. The median, okay, so we also need the median. So I'll use MED, or sometimes I just use a capital M for the median. So I'll kind of use both. The upper quartile, again, I will show you how to find all those numbers. And usually after I show it once, students are, well, that's not so bad. So I'm hoping I get that from you guys also. And the last one is the maximum. So you also need the greatest value in the list as well. So those are the 5 numbers that we need to make our box plot. In statistics, we call this the 5-number summary. So we can write that over here. We call this the 5-number summary. Okay, that's what that's called. So if you hear me say the 5-number summary, that's what I'm talking about. Those 5 numbers that you need to make the box plot. All right. I think I have an example next. Yes, I do. So the prices in dollars of 27-inch television sets at an electronics store are given below. Make a box plot of the television prices. Oh, don't know why that moved to the next line. Okay, so we're going to make a box plot. So there are 5 numbers that we need. So the first thing we always need to do, since one of those 5 numbers is the median, and to find the lower and upper quartiles, it's the median of the lower and the upper half of the data. Because of that, what do you think we have to do with those numbers first? Yes. Okay. We have to put them least to greatest. So let's rewrite them in order. So we got 188 is first, 192, and so you can either lightly cross them off, don't cross them off too dark, because then if you need to go and fix it, you might not be able to read your numbers, or put little check marks on top. What is the next one? Is it 224? 224, 225, 234. I don't see a 34. Oh, okay. Just checking. 239, 271. All right, so we had 271, 275, then the 286, 316, and 334. Let's see, I think off to the side over here, I'm going to list the 5 numbers that I need. I need a min, I need a lower quartile, I need a median, the upper quartile, and the max. Those are the 5 numbers we need. Now, when I find those numbers, I start in the middle. Okay? So I start with this one. That's the one I find first. Okay, so we find the median first. So there's 1 number, 2, 3, 4, and then 5. So my median is between those 2 numbers, right? So the median is between those 2 numbers. Oh, sorry, I had steps there. Is that 255? That sounds about right. You added them up and divide by 2. And I'm going to slow down here for a second. So 255 is our median. So we're going to write that there. So we put our numbers in order from least to greatest. We are now on finding the 5 numbers that we need. So I found the median first. Okay, so that's always the first thing I find. Then I find my lower and upper quartiles. And it doesn't matter which one you do first, but those are the 2 numbers you're going to find next. Now, the lower quartile is the lower half of the data. So your median right here split the data into 2 halves. This is 1 half. This is the other half. So we have 2 halves. So I'm going to cover up the upper half and find the median of the lower half. That's the lower quartile. So we go through, that's 1, 2, here's my lower quartile. So 224. Now you're going to do the upper half. So I'm going to cover up the lower half and find the median of the upper half. So there's 1, 2, that number's the number in the middle. That's the upper quartile. So that's 286. Now you can identify your minimum and your maximum. So I want to do the minimum and the maximum last because you need to use them to help you find the median and the quartiles. A lot of times students will circle them first and then they forget to use them to help them find those other values. So you have to be careful with that. All right, so 188 is the minimum. 334 is the maximum. There are my 5 numbers. So when you're doing a box plot, I expect to see all that work. Okay, I expect to see you put the numbers in order. You can do some work there where I've got the underlining and the circling and all that stuff. You can do all that, but you need to, off to the side, you need to list what your numbers are. Okay, you have to give me this list. Now we're going to do our graph. So we have to make a number line. Be sure to scale it correctly. I want to use a graph. All right, so you're going to make a number line. You want to scale it so that all your numbers fit. Okay? When you scale it, the space between these 2 numbers and between these 2 numbers and between those 2 numbers and so on is going to be the same amount. Okay? So you have to space it the same amount. So let's see, we're going to start, the lowest is 188. So I might start 180. Okay. The highest is 334. So let's see, if I count by 20s, would that fit? That'd be 180, 200, 220, 240, 260, 280, 300, 320, 360, no, 40, whoops. 340, 360, 380. So that fits, right? So I went ahead and went by 20s. You gotta make sure the min and the max will fit on the graph. Questions? So now we're going to start plotting points and lines. The minimum is 188. So I'm going to estimate about where 188 is. I'm going to put a point. On the top of the point, I'm going to write 188. Because if that's not there and you didn't have that, would you know that that was 188? Now you just know it's somewhere between 180 and 200, but you're not sure exactly what I wanted it to be. Okay? So make sure you write the number at the top. Then your lower quartile, 224. So 220, 24 is going to be a line. Write it at the top, 224. 255, so that's close, little past the middle here. 255. Upper quartile is 286. 286. And the maximum is 334. That's another dot, 334. So I've got all my numbers. The middle three numbers make the box. And now you have your whiskers. There's your box plot. So I have this extra comment down here to remind myself to discuss with you how it's broken down into 25% sections. So this section is 25% of the data. It's a different color. Okay, so right in here, that from here to here, that's 25% of the data. Okay, this first box part, in between there is 25% of the data. Between the middle and the end of the box, that's 25%. And between the end of the box and that last point, that's 25%. So we have split the data into 4 equal sections. A lot of times, some follow-up questions that can be asked would be, for example, what percent of the data or the television prices cost more than $224? Okay. Here's 224 right there. 25, 25, 25. That's 75%. So then you can have follow-up questions where I'm asking you for certain percentages. How much is less than 255? Right. Right. I heard someone else too. Yes. So here's 255. Less than that, 25, 25, that's 50%. Now, with the box plot, you remember that interquartile range? Yes. I'm going to now tell you how to find interquartile range. So remember upper quartile minus lower quartile? You know what those are now, because we just found some. So you can say UQ minus LQ. It's always the big one minus the small one. The greatest value minus the least value. Okay. And so we can go back to the previous slide where we did the box plot. The only time we really do quartiles is when we're working with box plots or the 5-number summary, those 5 numbers that we need to make the box plot. When we work with those numbers or the box plot, that's when we start talking about interquartile range. Okay? So you have to find those numbers to get the interquartile range. So there are 2 numbers I need. I need the upper quartile and the lower quartile. So let's go back. Okay, here's the problem we just did. My upper quartile is 286. My lower quartile is 224. So remember that, 286, 224. So now I can calculate 286 minus 224. And how much is it? Huh? 62? And that would be dollars because we're talking about dollars. So what that's saying is the middle 50% of the TVs we're talking about here have a price range of $62. So from the lower quartile to the upper quartile, the spread is about $62. That's how far apart they are. Does that kind of make sense? It's another measure of spread. It measures the middle 50%. How spread out is the middle 50%. All right, and this is the last thing, and we may not get to this example, which is okay. The outlier. Okay, I think the data we just looked at did not have an outlier, but sometimes we do have an outlier. So this will be something that we finish up next class, discussing the outlier and showing you what I mean by the outliers. But in general, an outlier is a value that is widely separated from the rest of the data set. Okay, it's either extremely low or extremely high. It can be on either end. If we look at this, we're talking example 3, just real quick, we're not going to do the problem. I just want to point out an outlier. There is an outlier in that data set. Which number seems to be kind of far away from all the other numbers? Which one's probably furthest away? 2.2, right? 9.1 is not too far from the 8.6. Those are pretty close. However, 2.2 is a long ways from the 6.7. Okay? So that would be considered an outlier. And there is a way to check it. Sometimes numbers might look like outliers, but they really aren't. So that's what we'll talk about next time, some ways to check to see if a number really is an outlier or not.